Welcome back to the deep dive. Usually when we talk about the cloud, it feels so abstract. It's this ethereal thing floating above us, storing photos, running our emails.
It is.
But today, we're grounding it. We are literally opening up the engine room of the internet. We're talking about AWS compute services.
It's funny you say engine room because that is exactly what this is. It's the horsepower.
Mm-hmm.
Without compute, the cloud is just a really, really big, extensive hard drive.
And it is massive. I mean, looking at the research for this, it felt less like reading a manual and more like walking into a Home Depot.
Yeah.
Where one aisle has a simple hammer and the next aisle over has a full-on robotic assembly line you can rent by the second.
That's a great comparison.
Yeah.
It's a toolbox that has just grown exponentially over, the last 15 years.
We've got everything here, from the basic building blocks that run Netflix to tools for like DNA sequencing, all the way to physical hardware you can drag into your own basement. It just feels overwhelming. If I'm a CTO or a developer or even just the student starting out, how do I not get, paralyzed by the choice?
That paralysis is real. It's the classic analysis paralysis. But if you look closely at the sources we've pulled together, there's a compass. There really is. The whole ecosystem is built on a single spectrum.
Okay.
Control versus convenience.
Control versus convenience. Okay, let's unpack it.
For on one end, you have total control. You manage the wires, the patches, the OS. It's powerful, but it's a huge chore.
Yeah.
On the other side, you've got convenience. You push a button, the code runs, and you go home. But the trade-off is you give up that granular tweaking. Our mission today is to figure out where on that spectrum you or your project actually belong.
I love that framework. Okay, so let's start at the control end. The heavy lifters, the acronym everyone knows, EC2, Elastic Compute Cloud.
The bread and butter of AWS, yeah, is where it all started.
In the notes, this is described as the raw building block, but what does that actually mean for someone spinning one up? Like, what am I actually buying?
You're renting a virtual slice of a physical server. But because it's raw, you are responsible for, almost everything.
Everything.
You get a dashboard, sure, but you have to pick the operating system. Windows, Linux, Mac OS. You have to manage the storage yourself, those elastic block volumes, configure the firewalls. It's not a managed service. It's infrastructure as a service.
It's like renting an unfurnished apartment. You get the walls, but you have to bring the furniture, hook up the utilities, and frankly, you have to clean the bathroom yourself.
And if the pipes burst, AWS handles the hardware pipes. But if the software pipes inside your walls burst, that's on you.
Now, to save us from installing Windows from scratch every single time, the notes bring up AMI's Amazon machine images.
Right. Think of an AMI as a frozen template. If you spend 3 days configuring a server exactly how you want it, security patches, specific software, user permissions, you don't want to do that again.
Never again.
So you take a snapshot, you create an AMI, and the next time you need that server, you launch from the template. It takes seconds instead of days.
That makes sense. But then we get to the menu, the instance types. I was looking at this list, and it's like the Cheesecake Factory menu. General purpose, compute optimized, storage optimized. How do you not pick the wrong one?
You have to know your bottleneck.
Yeah.
That is the secret. If you're running a massive database, your bottleneck is RAM.
Okay.
So you need memory optimized. If you're doing something like video encoding, your bottleneck is the CPU.
And then there's the celebrity of the moment. Accelerated computing. I saw NVIDIA's name plastered all over this section.
You can't avoid it. And this is where the cloud economics really, really shine. Buying a rack of H100 GPUs for AI training costs a fortune, millions of dollars.
Right.
But with EC2 accelerated computing, you can rent that supercomputer power for just the 3 hours you need to train your model, and then you just shut it off.
That's the elastic part. You don't have to own the factory to build the product.
Exactly.
But let's scale this up. EC2 is great if I need, a server, maybe 10? But the source material talks about AWS Batch. The name implies bulk processing.
Right. Imagine you aren't running a website that needs to be up 24/7. Imagine you're a hedge fund analyst crunching 10 years of market data.
Or a biotech firm simulating drug interactions.
Exactly. You have a million tiny jobs to do. You don't want to manually spin up 500 EC2 instances, log into them, start the script, and then shut them down.
No, that sounds awful.
So AWS Batch manages that transient workload. It provisions the compute, runs the jobs, retries them if they fail, which is huge, and shuts it all down. You focus on the math, not the fleet management.
Batch is the factory manager. Okay, so that's the heavy lifting. Lots of control, lots of complexity. Let's swing that pendulum all the way to the other side.
Easy button.
The easy button. Amazon Lightsail.
Lightsail is fascinating. It's almost anti-cloud in its philosophy. The modern cloud is usually all about infinite scalability and complexity. Lightsail is a box.
A box.
It's a virtual private server, a VPS. It's designed for the learner or the small business. You get a bundle. Compute, storage, data transfer, a static IP, all for a fixed price, like $5 or $10 a month.
So if I just want to host a WordPress blog or a simple app, and I don't want a degree in systems architecture.
You use Lightsail. It pre-configures everything, the networking, the DNS.
Yeah.
It's about knowing when you need to build a custom house versus when you just need a hotel room. Sometimes you just need a place to sleep.
I like that. But there's a middle ground, right?
Yeah.
I'm thinking about the developer persona. Say I write code Python, Ruby, Go, and I want that custom house feel, but I don't want to lay the bricks myself. I just want my code to run.
And that is the absolute sweet spot for Elastic Beanstalk.
I've always loved the name. It implies magic. You throw the beans and the stock just grows.
It kind of acts like it. Beanstalk is a platform as a service. So the workflow is you upload your code, just the zip file or the repository.
Just code.
Just the code. And Beanstalk handles the deployment. It provisions the EC2 instances, sets up the load balancer, handles the auto-scaling.
But unlike Lightsail, you can still pop the hood if you need to.
Yes. And that's the critical distinction. It automates the setup, but it doesn't lock you out of the underlying resources. If you need to tweak a config file on the server, you can. It's automation with an escape hatch.
The notes mention some pretty advanced deployment strategies here, specifically blue-green deployments. Can we break that down? Because that sounds like a safety feature.
It is the ultimate safety feature. In the old days, to update a website, you'd just overwrite the live files. If you made a typo, the site crashed, everyone panicked, the phone starts ringing.
High stakes.
Very. With blue-green, you have your live environment, let's call it blue. Beanstalk builds a totally separate, identical environment with your new code green. Spins it up, waits for it to be healthy, and only then does it flip the switch to route all the traffic over to green.
So if the new code is garbage, no one ever sees it.
Precisely. You just kill the green environment and try again. Zero downtime. It saves so many headaches.
That's a game changer for sanity. Okay, we can't talk about modern development without hitting the buzzword of the decade. Containers.
The container revolution. It changed everything.
There's a lot of confusion in the notes here between microservices and containers. People use them interchangeably, but they're not the same thing, are they?
No, and it's a really important distinction. Microservices is a design philosophy. It's how you organize your team and your code. Instead of one giant monolithic app where, like, the billing code is tangled up with the user profile code, you break it into small, independent pieces.
Like breaking a large department store into a bunch of little boutique shops.
That's a great way to put it. And containers are the shipping box those shops come in. It's the packaging technology. You bundle the code and all its dependencies, so it runs exactly the same on my laptop as it does in the cloud.
So microservices is the idea. Containers are the tool.
You got it.
Okay, so if I've packaged my app into these containers, AWS offers a few ways to run them, and this is where the acronym SOUP gets thick. ECS, EKS, ECR.EE. Help us out here.
Okay, let's simplify. ECR Elastic Container Registry is just a library. It's where you store your container images. It's secure. It scans for vulnerabilities. Think of it as the digital warehouse.
Got it. Warehouse is ECR, so how do we run them?
You have two main orchestrators. ECS Elastic Container Service is the AWS native way. It's what we'd call opinionated. It integrates perfectly with other AWS tools, and it's generally simpler to get started with.
And EKS?
EKS is Elastic Kubernetes Service, and Kubernetes is the open source giant. It's incredibly powerful, but notoriously complex to manage.
The K stands for complexity.
It might as well. People choose EKS, usually, because they're already using Kubernetes on-premise. Or maybe they want to be cloud agnostic, meaning they could theoretically move their setup to Google or Azure later.
Right.
But if you are all in on AWS, ECS is usually the smoother path. You don't have to manage the Kubernetes control plane.
Now we have to talk about the concept that seems to be eating the world. Serverless.
Ah, yeah. This is probably the biggest paradigm shift since the cloud began.
The promise is compute without the burden of server management. But there are servers somewhere, right? They didn't repeal the laws of physics.
You know, they're always servers. Physics still applies. But serverless means you don't know about them. You don't see them, you don't patch them, and Most importantly, you don't pay for them when they aren't working.
This is AWS Lambda.
This is AWS Lambda. It's event-driven. An event happens. Someone uploads a photo or clicks a button, and Lambda wakes up, runs a tiny snippet of code to process that event, and vanishes.
And the billing is calculated in, what, milliseconds?
Milliseconds. If your code runs for 100 milliseconds, you pay for 100 milliseconds. If no one visits your app for a week, you pay 0. Compare that to EC2, where you're paying by the hour, even if the server is just sitting there doing nothing.
So efficient. But Lambda is for snippets of code. What if I have a container, a whole app, but I still want that serverless experience? I don't want to manage the EC2 clusters underneath my containers.
Then you use AWS Fargate.
Fargate.
Fargate is serverless for containers. You just tell AWS, hey, here's my container image. It needs 2 CPUs and 4 gigs of RAM. Go run it. And AWS finds a spot in their massive infrastructure, runs it, and bills you for it. You never see the underlying server.
The notes call this removing undifferentiated heavy lifting.
It's a great phrase. It basically means stop doing work that doesn't make your product better.
Right.
Patching a server operating system doesn't make your pizza delivery app better. It just keeps the lights on. So let Fargate do it.
Speaking of keeping the lights on, we've built the app, we've chosen our compute. Now launch day arrives. 1 million users show up. If we don't have a plan, we crash. This brings us to auto-scaling and load balancing.
The traffic cops and the capacity planners.
Let's look at auto-scaling first. It's not just about handling traffic spikes, is it? The notes really emphasize cost.
Oh, it cuts both ways. Scaling out saves your reputation when traffic hits. It adds servers automatically. But scaling in saves your wallet when the traffic leaves. If you're running 100 servers at 3:0 a.m. when only 2 users are online, you were just burning money.
So it automates that breathing rhythm of the infrastructure.
Exactly. It matches supply to demand.
And once those servers are up, the load balancer decides who goes where. We have a menu of 4 types here.
It all depends on what layer of the network you care about.
The application load balancer, the ALB, seems to be the smart one.
It is. It operates at layer 7, the application layer. So it can look at the actual content of the request. It could say, oh, you're asking for the mobile site? Go to the mobile server cluster. Or you're asking for the API, go over here. It's intelligent routing.
Okay, contrast that with the network load balancer, the NLB.
The NLB is the speed demon. It works at layer 4. It doesn't look at the content. It just grabs the packets and throws them at the servers as fast as humanly possible. We're talking millions of requests per second.
There was a crucial security detail in the notes about the NLB. It passes encrypted traffic through without even looking at it.
Right. If you need true end-to-end encryption, where the load balancer never decrypts the data, maybe for some strict compliance reason, the NLB is your tool. It's a blind pass-through. It hands the locked briefcase to the server without ever checking what's inside.
Then we have the gateway load balancer, which seems pretty niche for firewalls and things, and the classic load balancer.
Classic is legacy. Honestly, unless you're maintaining a dinosaur, just pretend it doesn't exist. It's from a different era of the cloud.
Fair enough. All right, now I want to pivot to the section of the research that surprised me the most. We tend to think of the cloud as centralized, huge data centers in Virginia or Oregon, but this section is called pushing the edge.
This is where physics starts to matter.
Physics.
The speed of light. It's fast, but it's not infinite. If you're trading stocks or playing a competitive shooter game, a 50-millisecond delay because your data has to travel across the country is unacceptable. It's the difference between winning and losing.
So AWS is moving the cloud physically closer to us. First up, local zones.
Local zones are basically mini data centers. They're placed in major cities, Los Angeles, Miami, Houston, and they're extensions of the main AWS region. So if your users are in LA, you run your latency-sensitive apps in the LA local zone. You get single-digit millisecond latency.
But what if that's still not close enough? What if I want the cloud in my building?
Now you order AWS Outposts.
This concept blows my mind. You literally order a rack of servers from Amazon, they truck it to your office, they install it, and it just shows up on your AWS console like any other region.
That's exactly it. It's the same hardware AWS uses in their own data centers, but it sits in your basement.
But why would someone do that? Isn't the whole point of the cloud to get rid of the basement servers?
Usually, yes. But sometimes you have really strict data residency laws. The data literally cannot leave the building. Or, think about a factory floor with robotic arms. They need to react instantly. They can't wait for a signal to go to Virginia and back.
They need the compute right there, on the LAN.
Right. And the notes mention the LNI, the local network interface. which lets that outpost talk directly to your local equipment without even touching the public internet. It creates this seamless hybrid experience. Same APIs as the cloud, but the execution happens 5 feet away from you.
And finally, the most futuristic one, AWS Wavelength. This is tied to 5G.
This is really cool. AWS partners with telecom providers like Verizon, Vodafone, and they install compute hardware inside the 5G data centers at the edge of the network.
So before my data even leaves the cell tower network, it hits a server.
Right, it skips the public internet entirely.
Yeah.
For things like self-driving cars needing real-time inference or high-fidelity VR streaming, Wavelength just cuts the lag to almost nothing.
It's incredible, the breadth of this. We started with EC2, the workshop bench. We looked at Lightsail, the easy button. We abstracted everything away with serverless. And then we realized that sometimes you need the hardware right next to you with outposts.
It brings us right back to that central theme. It's all a spectrum of control versus convenience, but now we have a third dimension we have to think about. Location.
It makes you wonder where this is all going. We're seeing tools like Fargate, where the server is completely invisible to the coder, and at the same time, tools like Wavelength, where the server is physically everywhere.
It's converging. Yeah.
Here is the thought I want to leave you with today. If this trend continues, are we approaching a point where the concept of infrastructure just disappears? Where we stop being architects who build the house and we just become composers who write the music, trusting that the instruments will just appear wherever they're needed?
That's the holy grail, isn't it? Invisible infrastructure, where the code is the only thing that matters.
A fascinating future to prepare for. Thanks for joining us on this deep dive into the AWS compute ecosystem. Hopefully that toolbox looks a little less intimidating now. We'll catch you on the next one.